Welcome to part 2 of Prolog 1. This is Computer Science 305, Programming Languages. So we just got done talking about the basic concepts of terms and initial use of the Prolog language system. And so now we are going to talk about the next component, which is rules, right? So rules are needed because it's instead of having to go through the lengthy query that we did before to find, for example, the great-grandchildren of Esther, we would rather have the ability to have a nicer looking rule that kind of combines all that together so that we can reuse it and also make it look a little bit more readable. And furthermore, rather than having to create a whole bunch of extra facts, right, because we could easily go in and construct great-grandparent facts for every single potential family tree. We could create a whole bunch of different things. But rather than doing that, we have all the information we need right here and available to us in our existing system. All we need to do is just add in a rule which can utilize that information in order to, and the logical underpinnings of it, in order to actually provide us more powerful querying capability. And so this is sort of what rules do for us. And so the first one we want to do, and so when we define a rule, right, we have the head of the rule, which is just looks like a compound term, right? It actually is a compound term that starts with an atom and then defines the variables that we are going to use to as a part of our unification. And then we follow it by the colon dash, and then we define our conditions, right? And our conditions are typically conjoined with the conjunction operator comma, and then it ends with a period. So we can go ahead and define this. We can say great-grandparent, and then we give the variable ggp and ggc. And so this is defining the rule great-grandparent of arity2, and it can be read basically as saying ggp is the great-grandparent of ggc, and then we will define this saying parent ggp, gp, and parent gpp, and then parent p ggc, right? And then end that with a period. So basically, rules just are going to tell us how we can prove something. They give us the method by intermediate method by which we can prove something. And so what this is saying is, to prove this, basically we have to find some GP, right, such that GP is the parent of P and P is the parent of GGC. Thus, and then that conjunction will then say that GGP is the great-grandparent of GGC. So, with that, we've defined our program to incorporate that. We'll save it. And I'm going to reload Prolog and get rid of all these massive errors. So we say consult relations again. And now we can run great-grandparent as necessary, right? So if we have this great-grandparent, Esther, great-grandchild, hopefully this will work. And so if we do this and we've defined it correctly, it should return that the great-grandchild of Esther is Holly. And it worked. And we see that there's no other choice. Now we could actually do this where we just say ggp with two variables, and it comes out that Esther is the great-grandparent of Holly. Herbert's the great-grandparent of Holly as well. And then that's it. So now we have that. Note that this only shows the initial query and the final result. But inside of Prolog, there is a intermediate set of goals, right? There are things that are actually happening inside, allowing Prolog to walk backwards chain to solve these the rules in order to generate the correct, in order to determine if it can prove it or not. Right? So essentially what it does is the first goal is the initial query. The next is what remains to be proved after transforming the first goal using one of the clauses, right? In this case, the great-grandparent rule, and so on until nothing remains to be proved, right? And so essentially, it's going to use our database of facts here and rules. And so the first thing it's going to say is, we have great-grandparent. It's going to bind GGP to Esther and GGC to great-grandchild. We'll then check if there's a parent such that Esther binds to GP and it's going to define this whole next set of clauses where we've now moved Esther into GGP, as we see here, and then it's going to continue along trying to find a binding for GP, right? It does. It finds one for Margaret, and then tries to unify that with so we have Margaret and P, right? And we're trying to find a binding for P such that, and then we do for Kim, right? Margaret is the parent of Kim. And then we go down through and we see Kim, and we're trying to find a great-grandchild or the child of Kim. We find Holly, and then that's the end of the first solution. We can also find the second solution, which was Herbert and Holly as well. Now, we can further refine this, right, by developing another rule, which we'll call grandparent. So we'll do that. We'll say grandparent GP GC, right, which we then simply define as GP is the parent of P and parent of P is a parent of GC, right? So this is a simple rule. And then we can redefine our great-grandparent clause to simply be grandparent GGP P and parent P GGC. Oh, I'll just copy it. Be easier. Good Lord. Okay, everything's good again. So now it's all exactly the same in the case of this, but now it's going to have a little bit easier time. It just has a secondary clause that's going to go to prior to in a different trace than what we saw before. So we can also define recursive rules that allow us that can essentially use themselves, right? So just like we normally think of, we have a base case. So we're defining ancestor. Ancestor is a recursive rule. We can define it as looking up, is there a parent XY? That would be the base case. Otherwise, we are looking for a parent ZY and then ancestor XZ. Such that, so it's saying ancestor is either, is basically saying that it's either we have some value XY, right? We're saying Z is the parent of Y and X is the ancestor of Z. And that way, otherwise, X is just the parent of Y. So, we can, and then Prolog will continue utilizing this. Now, if we don't have that base case in there, it will fail just like it does for any other system that allows recursion. So we'll go ahead and define that as well prior to loading this all up. So we say ancestor XY, parent XY, ancestor XY again, and then this is the recursive, so we say parent ZY and ancestor XZ. Okay. So we've done this. We can then, we'll load this up. And now we can run a couple of these queries. We'll say ancestor gene, right? Should return false because you cannot be your own ancestor, and it does. And we ask, is Kim an ancestor of Holly? Returns true. And then finally, we want to check who are the ancestors of Holly. So we say ancestor A Holly, and we get Kim, Margaret, Esther, and Herbert. What we expect to see overall, based on all the knowledge that we have just from the parent facts that we know. So it looks great. So far we've seen the complete core syntax of Prolog. Basically, we have three things. We have a clause, a fact, a rule, and a term list. This is all we have. It's pretty simple. We can define a clause as either a fact or a rule. A fact is a term followed by a period. A rule is a term followed by a colon dash followed by a term list followed by a period. And a term list is simply either a term or a term separated followed by a comma followed by a term list. So it's pretty easy, right? It's very simple language, at least syntactically. We'll get into a little bit more as we start talking about operators lists and a variety of other things. So Prolog, and I'll bring this back up to full screen. So a Prolog is really has two different phases, right? It's both procedural language and an imperative language. So the procedural side is like we're defining rules, right? We define rules to solve something. The procedure of solving is by the proof procedures underlying Prolog. But it follows a very logical structure. And we define that as we define our different rules that are then the queries that we execute. On the other side, we have the declarative, and this kind of gets into basically it's a rule is also a logical assertion, right? So we are asserting whether or not something is true, and so and whether or not we can make something happen, right? We define a formula. We do not say how that formula is to be performed. We just assert that it's either true or false. And so essentially we can think of, if we were to write this out as logic, for all GGP, GPP, and GGC, that will effectively become, we are asserting that parent of GGP, GP, and parent of GPP, and parent of PGGC implies great-grandparent GGP, GGC. So if we want to think about that for logic, and there must be, in order for this to be all true, there must be something that binds GGP, GPP, and GGC such that this assertion happens, right? How that actually is done is the procedural side of Prolog, its underlying algorithms for unification. Declarative languages are very simple to understand. We describe how something works rather than tell how something works, right? Imperative says, this is how you do it. Declarative says, this is what I'm looking for, right? It's more, we'll say that it's much more mathematical, if you will, or logical than exactly, very side effect and procedural like in Java or Ruby was. So declarative languages are like ML, Prolog, versus imperative languages like Ruby, Perl, Python, etc. Declarative has certain advantages. Typically, we are not focused on side effects or interdependencies. Declarative languages tend to be simpler with their semantics. It's easier to develop and maintain correct programs. They're usually much higher level, more abstract, and provide more automatic programming. We describe problems and we let the computer figure out how to solve them. That's sort of the concept of declarative languages. But for the most part, for the students who have been programming in the imperative way, it's a mind shift that you will have to make in order to understand how to program in the declarative way. So anyway, but the interesting thing is Prolog does both of these, right? It's declarative in that we are focused on describing the logic of a system, but it's also procedural because we have to worry about clause ordering, conditional ordering, side effect predicates, similar to like consult and things like that. You need to be aware of that as you write your code. So anyway, that gets us through this second part of Prolog 1, and the next step we'll talk about operators and lists, and this should be interesting.